Hello, everybody. Welcome to the DePIN podcast. I'm your host, Tom Trowbridge. We're excited to bring you interviews with the key founders in the DePIN landscape, investors, and ecosystem partners. This is an exciting time for DePIN, and this year we're going to be meeting even more founders, learning about the projects that they're building, about the traction they're getting, and about the revenue that they're generating. The podcast is brought to you by Fluence. Fluence is building a decentralized compute platform. It's a project I'm a co-founder of and really excited about. So buckle up for this year. Please subscribe to the channel, listen to us on Spotify or Apple. And of course, if you are around any of the large conferences, come to our DePIN Day, where you can meet these founders on the Fluence team in person and hear from all the ecosystem partners as well. So look forward to seeing you in person, and let's get going on this podcast. Hello, everybody. Welcome to the DePIN podcast. I'm your host, Tom Trowbridge. I am thrilled to be here with Alessandro, the co-founder of Acurast. Welcome, Alessandro.
Welcome to you as well, Tom. Thank you so much for having me.
For those that don't know, Acurast is a decentralized compute network, and that's what Fluence is does something similar, but Acurast is very different in being mobile only, and that is a really interesting and important design and technology choice. So let's get into it, Alessandro. Let's talk about mobile only. And I think a lot of what you're doing is actually kind of emphasizes some of the things I say a lot about DePIN, about the kind of advancement we have in hardware. But why don't you dig into kind of the benefits of mobile and the type of compute you're doing?
Yeah, sure. So it might not be a surprise, but my background is in mobile security. I used to be working at Credit Suisse way back in the days when the bank started to onboard mobile devices for all sorts of things, starting with the mobile banking, which was perceived in the beginning more as a risk because it was new technology, a new way to access your bank account. But I basically was at the bank when then the shift happened to use this really as a tool also for all internal processes at the bank, so for relationship manager and so on and so forth. And obviously the concern about security was very, very high. But the push for the adoption of this technology and hardware was also equally as high. So that was quite interesting to see that development, because I also worked personally with the teams over at Apple and at the Android enterprise team to basically share with them our requirements, share with them our concerns. And I saw firsthand how all of that led to hardware becoming more and more secure, and basically like we have today, these devices that you can use for all sorts of security relevant things, yet they never have the privilege of physical security like a server. And for me, the big fascination around Acurast basically is coming from the simple fact that this is a device that is readily available everywhere, and has put in a lot of R&D from huge companies. I mean, looking at Apple alone, they invest about 33 billion a year in R&D, and the iPhone is the thing that yields them more than 60% of their revenue. So this shows you how much effort is actually being put into the design of these chips and so on and so forth. And I always found it funny that people don't realize the full potential that these literal powerhouses have. And then I got very excited when I first saw that our users started to basically create entire farms. So setups where you had 100, 200, 400 devices all interconnected via USB-C. And then I realized that, this really is something that allows us to push for a more decentralized future. And got me very excited to even more do more in this space, actually.
Well, I think, that you just hit on about 4 different topics that I would like to go into in depth in each one of them. To get back to the core of my question, I think you just touched on it, but I think you're saying that phones have a high level of sophistication. I think I've read in your materials, they have TEs, trusted execution environments, so they can be secure, and so they are capable of doing more than people realize, and some of that more is compute. Now, obviously, we see phones in the DePIN space being used to do a variety of stuff, right? They collect sound, they collect images, they collect video, right? Their phones are a device that are kind of crucial to a lot of DePIN platforms because the sensor technology has advanced to a level that we couldn't have imagined 10 years ago. But I think your point is that the critical pieces for you guys is both is the computation capabilities of the phone and also the security of the phones. Is that right?
Absolutely, yes. I think the security and then ultimately also scalability of it, right? Being readily available everywhere in every household, I think is what got me as well real excited as using this device as a basically foundation for a decentralized compute network. Yeah.
And then help us understand, because when we think compute, when I think about from Fluence side, we talk about servers, we talk about data centers, we talk about the hyperscalers employing 650,000 CPU data centers around the world, like massive compute scale. They're solving, some pretty complex problems. But I think from what I'm guessing, there is a lot of compute which does not need that level of resource dedicated to it. So help people understand the type of compute that you think that phones are appropriate for and the decentralized network is appropriate for.
Yes. So obviously, the big limitation of mobile devices is that they simply cannot scale vertically, to the level of a server. So you can purchase a server today and plug on a couple of CPUs, add a couple of 100 gigabytes of RAM. Obviously, that you cannot do with a single phone. However, the compute unit of the mobile device nowadays offers to you 8 cores, 8 gigabytes of RAM on average. And if you take a look at what the Google Clouds, AWS, and so on and so forth are being used today for, you will realize that most of the compute fits exactly in that format. So 8 cores, 8 gigabytes of RAM, that is already on Google Cloud, a $300 machine a month, right? That at least here in Switzerland, if you want it in the Swiss location, probably in the US, you will pay only $200 US dollars. But still, it is already some money, right? And that's basically what a single mobile device is capable of offering you in terms of compute. Now, the full equation is not as simple, obviously. Because mobile devices do have some shortcomings that you have to make up for. And those shortcomings are exactly what the Acurast abstraction or the Acurast network is there for. Basically, abstracting away the full hardware component to the developer that is deploying an application so that they can just use this in a very similar way how they use something like Vercel or AWS, Lambda, or Google Cloud Functions. So that is the kind of compute that Acurast is offering. But I think the big differentiation is that the compute all runs in a confidential compute environment by design. So we touched on the hardware security module just very briefly before. That's the module that you utilize so that you can do your mobile banking, you can manage your wallets, you can manage your identity. That very hardware, which comes pre-shipped with almost every smartphone today, allows you to create an environment that has two very interesting aspects. For starters, it gives you an attestation from the hardware manufacturer. This means that I know that the device is real, and I know so because the device runs some internal checks that the hardware manufacturer designed and defined. And based on those checks, you can say whether the environment is in its full integrity or not. One of the very special things about Acurast, also, if you go on our social media, Twitter, Telegram, and so on and so forth, you will see that people are very proud in showing their setups with hundreds of devices. And the reason is they cannot simply just purchase a virtual machine somewhere that is invisible, basically. But they really have to actually purchase the physical hardware and put it to work. And the other thing is this confidential execution environment acts as a black box. This means that I don't need to trust you as my compute provider with my data. I also don't need to trust you that you actually do the execution that I ask you to do. So the environment offers you these two properties of confidentiality and verifiability, which ultimately means that it really becomes an abstraction where you don't need to trust anyone to be providing you with that compute, with an asterisk, because there is still one case that we'll touch on that you still need some reliability on the other side, but you don't need to trust this other party, and you can just kind of deploy workloads and applications just like you would deploy them on a local machine, but you can scale them just like on a cloud setups. The last point, which I was also not aware when we first started with Acurast, is that there is an immense push from these large hardware manufacturers to basically push all these AI tasks to the edge. So you mentioned that they're increasing their computational power, they're increasing their data center sizes, and so on and so forth. But they're still struggling a lot with a big number of AI tasks. So what they did was actually pretty simple. They offloaded the investment of the hardware to the user. So basically, you purchase now a Samsung S24 with 16 gigs of RAM and hardware acceleration for AI for $1,000, and I can just then utilize that hardware to provide you a service that you pay for. And with Acurast, we flip the script on its head and basically say, well, you know what? That hardware is very useful. You can utilize that to also run LLMs in a confidential setup. But in this case, you're actually offering that compute to somebody else, right?
So, question then for you. What I'm trying to get, I think you've answered this question, but just to confirm it, the jobs that you are thinking of, or the use you're doing, it's effectively dividing it among multiple devices. You talk about abstracting, right? So then the level of complexity it would think to be high, because you are then, sharing workloads between, dozens or hundreds of devices. Right. And so then you have to be sure that you have connectivity, those devices. You've got to be sure of bandwidth usage, because it's not just the compute, right? But then the data has to go there and come back, even if it's encrypted, et cetera. So you worry then you have latency things to solve. You also have coordination kind of, challenges to solve. Is that right?
I mean, you're going in a topic that I love, that is very technical. I will try to structure it in a way that also non-technical people can understand it. The Acurast protocol acts as an orchestrator between whoever is providing compute with whoever wants to utilize that compute. And this means that I can go there and advertise the compute that I have available. And actually that happens all automatically because it happens directly from this trusted execution environment. So everyone benchmarks the hardware that they have and say, hey, I have a Samsung S24. This has this and that acceleration for matrix multiplications. This has this amount of RAM, and so on and so forth. Just I advertise whatever I have. And then on the other hand, a developer can say, look, I want to run a Qwen 14 billion parameter model. I need to be running on hardware that can actually accelerate it because it's interactive. Like my use case is interactive. And then I advertise that, and I will only be matchable to workloads that have that are meeting those restrictions. So there is then a matchmaking happening. We have, for instance, devices that are not as powerful as a S24. We have devices that are like just 2 gigs of RAM. We already know today, however, as a developer, I know that a 14 billion parameter model requires at least 12 gigs of RAM. So I need to set that restriction. So that complexity is handled, this specific complexity is handled by the Acurast protocol, which does not solve yet other problems that you were mentioning, namely, for starters, the problem of coordinating as a high-performance compute cluster a certain workload. And one of those workloads can be, I want to run a model, just to stay in the LLM space, I want to run a model that does not fit on a single device. And not fitting means it does not fit inside the RAM. So it would effectively become useless to utilize that device for that specific model. This is basically where the clusters that I mentioned before come into play. Because I can also advertise as a manager, and the manager in our context is someone who owns one or more compute units, owns one or more devices on-chain. I can advertise that I have a cluster. And if I have a cluster, that means that that thing acts as one entity. And with that cluster, you also get interconnection, which is over USB-C. This means that for today, usually that's a 10 gig connection. But now with USB 4 and so on and so forth, that can grow up to 80 gigs, 80 gigabits of connection. And then obviously this means that your task needs to be rewritten so that it is capable of utilizing that sort of intercommunication and the scheduling and everything. But we already offer you the tools basically to do exactly that. Yes, I hope that answers most of the various
No, it does, and that's interesting, because this hits a third thing I wanted to talk about, but which I think is almost the institutionalization of DePIN. And so you're a little referencing here is, I've seen, and I've remarked on this before, you may have heard it, that, you took Bitcoin, went from people mining in their basements to data centers run by publicly traded companies, massive institutionalization. And now, even with Acurast, which is using mobile devices, a big use case is, we won't go quite so far as say institutional, but is still, almost like a very dedicated user that is effectively, implementing a hardware arbitrage by the cheapness of outdated, you call it outdated, whatever, but unused mobile devices that they can acquire very inexpensively, that are basically underpriced given the compute resources inside of them and given the security inside of them. And so you are able to basically monetize
and through you, they can monetize these, effectively latent, unused, unusually cheap resources, right? So that's what this is pretty interesting, because you're saying this is effectively a hardware arbitrage where people want new phones, buy new phones, and the old ones are trading at a fraction of what the actual compute resources are worth. And you are a tool to help monetize that. Is that accurate also?
Yes. Yes. The only thing that I would, so at the moment, obviously the Acurast team plays a central role because we are contributors to the core protocol. But what I ultimately want to see is that this grows way beyond us, and actually is really just a client, a tool, a set of consensus rules that you say I want to comply with, and by complying with those consensus rules, you're part of the network. There is no need of anyone. Like it's the protocol that is ultimately offering you this specific service, and it's not us. I mean, already today it's not us. We have more than 50,000 devices online on the test network that are hard beating and providing their compute, which is already quite like for Swiss standards, that is already quite a big data center. And we don't own those devices. Like these are all owned by the users. And I think that's what's so cool about this, that it's really just through software that you're organizing a bunch of people to incentivize them to provide this protocol with the resources it needs, so that you can grow something that goes beyond the initiator. I think this is ultimately what for me also DePIN is all about, what for me decentralization is all about. I mean, looking at Bitcoin, you're saying exactly what has happened, right? Because all of a sudden the incentive was so large for people to start mining that people made a big business out of it and started to institutionalize everything. But it still holds true that I can today design my own hardware if I want to. If I have a clever idea how to pump out better hashes, more hashes than other ASIC miners, I could do that, right? It's really just I need to comply with the rules of the Bitcoin network, and then I can participate there. And I think this is ultimately what this whole DePIN movement should be about, that it grows beyond the initiator to a scale that no one thought possible. I mean, look at Bitcoin right now. You have entire countries discussing this, and it basically started as a weekend project of someone that had this vision and thought that it would be cool.
I agree with that. I think the challenge, though, with DePIN is that, and I think this is true with Acurast as well, is that you need customers, and all DePIN projects need customers, and customers rarely just fall out of the sky, and it takes a focused business development effort to go get them. And right, and that business development effort then relies on product, and product relies on people building and doing it. There is more centralization, I think, in DePIN projects in general, at least at this stage. And I think that's probably necessary at some point. And there are certain projects, like look at Filecoin, which is very focused on being a platform and not a product, with a goal, like a protocol, effectively, where it very much wants people to build products on top of the Filecoin protocol. And that's great. And I think that ultimately can work. It's a model, but most DePINs seem to me are more narrowly product focused to get customers and revenue. And I think your vision makes a ton of sense down the road. But first, we got to prove traction, customer adoption, right? And get the product market fit humming to then be able to expand and build on top of it. I'm sure you agree with that. I'm sure you're busy on the BD side as well.
Absolutely. And I think it is a tricky part, but what I have not seen yet happening in the DePIN space, and where I see a huge opportunity, is basically scaling the BD side also on the other side. You know, for instance, I met with a couple of people at various conferences that now have setups for Acurast. These people all have some jobs somewhere else. Like someone came over that was working at a Swiss pension fund, and someone else that is working on a centralized exchange side. All these people have jobs there, and what I think, and maybe this is a little bit a naive vision, to be honest, but what I do believe is the big power is basically if you can activate those people as well as being your extended partner network, your extended sales force, right? And for that, obviously, you first need to prove yourself that you're able to convert customers, you're able to deliver the value that you said you would with your network, and you're able to have a differentiation factor compared to the other offering that is available, right? Absolutely, that you need to do first. But I think once it's very clear for which benefits someone is utilizing your platform, like what are the unique selling points of your platform and your DePIN ultimately, I really think that the more exciting part is then to start activating your community because they have all incentives as well to do that.
Listen, I'd love to see that. And I think at some point that might be the case. I think it really depends on, I think that BD is a harder role and sales is a harder role for people who already have jobs to do it part-time, at least at any type of scale. And so I think that, it's not quite, maybe they could be a referral network to a BD team. That's more likely to me than actually being out there, closing deals. Let's back up though, because one of the other things you sort of touched on earlier, you touched on your background. And what I think is interesting about so many DePIN projects, and you guys kind of, I think, fit into this as well, is that a lot of the team members come from the sector in which their project is in, and then discover DePIN and discover crypto as a way to kind of build on their expertise to execute a particular vision and a particular kind of product solution. And it sounds like your background is very specific to mobile, to security, to compute, right? And so if you would maybe expand on some of the comments you made earlier, because I think it fits right into that sort of DePIN sector expertise narrative, which I've seen kind of permeate through so many of these founder discussions I've had.
For me, it's always like, talk is cheap, show me the code, right? And I think there is a little bit also a cultural aspect to this, because I believe that Swiss people in general are quite humble and like to also underpromise, which puts us at a disadvantage to very to embarrassed scenarios. But the point was always that if, like, I wouldn't start a project where I don't know yet that it has the potential to really work, right? And I think that for now the specific use case of utilizing mobile for compute, there are tons of limitations from the mobile operating system that you have to overcome. You have to understand how they work and so on and so forth. And also, like, all these security concepts, they're all learnable. I'm not saying that it is rocket science and no one is capable of ever learn these specific things, but it's just because we already knew those things that we felt really confident and comfortable in creating such a network. That's probably kind of the same thing if you take a look at something like GeoNet, where they know and understand that there is a market for this kind of data, and that the way that you are collecting currently that data is just not let's say efficient, right? They had an arbitrage on that side. I think it's always important to be a little bit naive. I think you need that because otherwise you will not think out of the box, but still have some link to reality and having seen things, right? Another thing that I did before working at the bank was I worked for a company that was also selling as a independent software vendor SAP plugins, SAP add-ons. And what I learned there, this touches a little bit on the topic that we had before, is that the big power behind SAP is not necessarily their software, because the software is total shit, but it's that they created business community around their software that is very, very valuable and has all incentives aligned. The partner network of SAP is what creates all that value because it's also the multiplier that they have. And I think that you're saying the right thing, right? Someone that is doing just part-time BD will have it really, really hard to do so. But if there is some sort of economic incentive around it and you can start building a business, you will start with part-time and then eventually see, hey, this actually is capable of scaling, and then start applying more and more of your resources into that model. Just like these SAP partners are creating a ton of value for SAP, because you need to still purchase the licenses. But in the meantime, they're able to at least double or triple the value that is being created for the customer with add-ons, their services, and so on and so forth. This is effectively where I want to go with as well Acurast, and obviously the product that you get out of it needs to be able to compete with the traditional offering, because in the Web3 space, sure, you will find people that care about decentralization, but in the general business context, they don't necessarily care about the fact that it is decentralized. They just want that the stuff is reliable and works, right? That's ultimately, yeah.
Well, no doubt. So let's go there and talk about customers, talk about pricing, talk about value add. So talk about the value proposition. I assume it's a lot cheaper. What type of customers, what segments are you going after now?
Cheaper always depends, right? Because we are a general compute platform, so you can host Node.js backends with Acurast. You can host websites, you can host databases, you can host distributed storage solutions. You can basically use it in a very similar way like you would be using a server. But if you then take a look at LLM specifically, maybe because of venture capital, maybe because of very efficient hardware, I don't think that competing on tokens per second is the metric that makes most sense for Acurast, because I think that that's a race to the bottom, and is not ultimately what will deliver the value that you're looking for. The specialty around Acurast is really this confidential compute, right? And the fact that these LLMs run fully inside that environment, and also that environment can work with cryptography. It can have a wallet. It can do some API calls for you. It can do some on-chain transactions for you completely in a self-custody way. It's basically like you have an extended compute force that is fully tamper-proof. And I think that is the USP behind Acurast. It's not necessarily that stuff will be cheaper and so on and so forth. Obviously, I believe that it will be cheaper for the simple fact that the prices you see on Amazon and Google are horrendous. Like they're really, really high compared to what it actually costs you to run those servers. Like their abstraction and added margins on top are huge. And then obviously running a mobile device on idle because it's such a efficient chip will also have and translates to lower operating costs, which obviously translates also to lower costs. But I don't think that you can just say Acurast will be cheaper for every sort of computation. I think for a specific set of computations, it definitely will, but it's not necessarily the thing that I'm after. I think that it should be fairly priced and people should use it for the properties that it offers you.
Okay. And so what type of customers then? You're effectively saying you think security and confidentiality are going to be the primary the primary value proposition, value driver. So is that LLM? Are those LLMs, or what are the users that are going to value that, you think, most?
We see that Acurast is being used for quite important and big projects to automate on-chain processes. For instance, there is XCBTC, that is an alternative to WBTC. Currently, they're managing about 1,000 Bitcoins on-chain. And all of those Bitcoins are entirely, like the wallets of those Bitcoins run inside Acurast trusted execution environments. The full automation, which is completely self-custody, runs inside the compute provided by Acurast. I think this is one of the prime examples where you couldn't be using anything else, to be honest. But I don't believe that everyone will be as sophisticated. There's also other things in the Web3 area where people are using this for AI agents, where the entire agent and LLM is actually running in the trusted execution environment. What I think is one of the more interesting topics that I'm currently looking at with a couple of clients as well here in Switzerland is the ability to run confidential AI on these devices. So basically, you're sharing your enterprise data with them, but the data never leaks and cannot be tampered with. That is one of the use cases that I think works very well for the sort of infrastructure that we have.
That definitely is interesting. I think that confidential LLMs and confidential data confidentiality, back up, proprietary data is where a lot of the value is going to be down the road. I think, right, as LLMs run out of data, the uniqueness of data sets will become more and more valuable. So keep that confidential. I can understand for sure. Help us understand how you're designing the token economics to drive this incentives. Clearly, you want to reward everyone with devices. How have you structured these token economics to do so?
We started with a very simple model that we had to revisit. And this very simple model was basically that everyone is capable of just specifying the price of their resource themselves. So we thought, okay, you're providing compute to the network. Someone will get matched to your compute. You can set the price of that compute. It turns out that model is a little bit slow in adapting with regards to demand and supply of the compute on the network. That's why now with the new model, what we basically said is, look, if you're proving to the network with a heartbeat that you have compute available, then we will be able to reward that through inflation. If someone starts utilizing you for a specific computation, that obviously is way more valuable. And that's why there is a factor where people will pay more for that compute, and that factor basically is then just multiplied by the baseline reward that you receive. And this does two things. On one hand, you have more consistent rewards as a user based on the compute that you provide. So basically, if you provide just a very weak device, it will not earn as much as a device that is more powerful. And ultimately also works with the supply and demand side of things, because if we will have a ton of devices similar to a Bitcoin network, the more miners you actually have, the less the single miner will actually start receiving, until it becomes no longer attractive to be participating in the network, and then they exit the network, and it becomes more attractive for the other participants. This is basically how the model works. It's quite simple, but we already had to redesign it because we already.
But if you have inflation, first, that inflation is divided equally among all devices on the network?
It's not as easy. This goes already quite into the details of the implementation, but we have various pools where this inflation is going into. And if you participate with just a compute unit, you don't have a stake, you are not ensuring that your compute unit will be available tomorrow. If you just participate with just a compute, you score your compute, and then based on that score, you receive a relative allocation to this first pool. Then there is a second pool where also the stake plays a role, where you say, look, I have this amount of compute, and I plan to be available over the next couple of months. And by having that statement, you receive a weight in this pool, which is relative to other people also participating in that pool. And what you're receiving as a reward as someone that participates is all the rewards from the various pools that you're participating in, basically. And this happens all completely automatically, where you just onboard more devices.
And those rewards then are a fixed number of tokens based on inflation that are allocated to each pool, divided between the devices in the pools based on the amount of compute they have, right? And then if they switch to having a paying customer comes on, great. Now they're no longer getting a reward pool, but they're paid a multiple of that reward. But the reward is in tokens, and they're being paid in fiat, you would think, right? Or not?
Is yet another topic, which is also very interesting to talk about, because for us it was important from the beginning that you should be able to earn in the currency that you want, and you should be able to pay in the currency that you want. So basically, fully leverage composability of DeFi and Web3 in general. And what happens is that if I'm a paying customer, I say I need compute for a month, 64 gigabytes of RAM, this amount of cores, whatever, and I pay in US dollars. Now, what happens is basically that you have a credit card connected to an on-ramp. The on-ramp then converts to Acurast tokens, and then Acurast tokens are being transferred to whoever is providing the compute. Now, whoever is providing the compute can do the opposite thing. They can say, I want to get paid in Bitcoins. If that is the case, then automatically the protocol says, okay, now you received this amount of Acurast tokens. We're swapping them back for Bitcoins and giving this person directly the Bitcoins that they are after. And this obviously applies also to US dollar to US dollar, USDT to USDT, if you want, and so on and so forth. And in the process to reduce the inflation, a certain amount of the payment is actually burned.
So there's a fee burn, effectively.
Yes, correct.
There's a fee that you take that burns some of it. Gotcha. Okay. And so the use then of the token sounds like there's some of it is used to stake, and there is some, small amount of fee burn. Is that accurate? So the token is used for payment behind the scenes. Some of it is used to stake to guarantee your devices online for a certain amount of time. And then there is some amount of fee which is burned. Is that right?
That's correct. One other very important aspect is that there is a decentralized governance system. We actually start from day one with quite a large allocation of our tokens in a treasury that is all controlled by the governance of those token holders.
Well, help us understand how big you think this can be. Like you've been in this industry for a while. What's your vision for number of devices, scale of workloads, customers? Like, help whatever metrics you think make sense. Help us think about where you want this to go.
I think that we'll be reaching very soon now the 100,000 devices spread across the globe, which I think will be already a quite nice milestone. The milestone after that should be in the region of 1 million. And as soon as we are reaching 1+ million, we are actually in a realm of compute units that is very similar to what an AWS and Google has individually, right? My ambition is to basically be able to provide this compute in all sorts of regions that currently don't, like are completely underserviced or not serviced at all, and have the largest compute network available on the planet. I think the scale of the mobile devices will allow us to actually reach that, and also looking at how the whole network is growing, which obviously will come with more and more complexities and everything, but I think that should be doable. And as soon as we are able to reach the compute amount that an Alibaba or a Google is providing, I think that would be a huge milestone, and basically proving that this crowdsourcing of compute actually works.
Awesome. Listen, that is a great goal. I love it. And, can't wait for you to get to 100,000. That's obviously a great number of devices online. For people watching, how do they sign up? How do they add their devices to your network to begin contributing and help you get to that goal?
So there's a couple of ways how you can contribute a device. The easiest way is basically through an app that you can install through the stores. And I think that's an easy way to onboard. Once you get more into it, you will see that there is also a mode where the device completely is locked down and fully dedicated to the network. That is what we call Acurast Core. And more details on that mode, as well as the apps you can find on Acurast.com or hub.acurast.com, is basically where you will start your journey with Acurast. If there are any sort of questions, technical, educational, whatever, you can always reach out on Telegram, Twitter, or also Discord. The community is very happy to be helpful with all sorts of things, like which device you should buy, or maybe you have a great deal to buy a lot of devices. So then you can also ask in the community what they would think would make sense or not. So yes, those are the
Awesome.
channels.
Well,
Cool.
listen, great. Well, now we've got it, and hopefully this will get you a little closer to your 100,000 device goal. Listen, Alessandro, thank you for joining. Super interesting, and wish you all the best. And want to see more of your neon yellow T-shirts at the DePIN Day event. So thanks for all your support of the events, and look forward to seeing you at the next one.
Thank you so much, Tom. Thank you for having me.
The DePINed podcast, the place where we explore real-world use cases unlocked by crypto. That's all for today. Thanks for watching to the end. If you enjoyed this episode, please help us grow. Add a like, add a comment. And of course, if you have anyone you think we should be talking to or have on this podcast, either leave a comment there or reach out. But thanks for watching, and we'll see you next week.